Hello and welcome to the Unit 3 past paper that I gave you to practice with and take home. This is from a year ago. It's the June 2015 paper and it's a Unit 3 1.5 hour exam at foundation level. As you can see, it's the old format where you have the marking schedule down the right hand side. The new format makes the most of the full width of the top, and all your details are now contained across the top. So on the day, don't be fooled by a different layout to your front page. As always, I have the shortcuts either side of the front page, so if you want to go directly to a question, please use the YouTube shortcuts to that question which are provided. Let's take a look at the front of the paper then. So Unit 3 Foundation tier is the important piece, and it's a 1.5 hour exam. The start time for the exams at Preston College is not 9 o'clock, it's 09:30. The two most important parts of the paper are that you can use a calculator, so please remember to use a calculator even for the most simple of calculations. Also, you'll need your mathematical instruments, and that's absolutely necessary for Unit 3 because being the geometry paper, there's lots and lots of drawing that you'll be expected to do. On the instructions, all the good things where you're required to draw in black ink. However, diagrams should be in pencil. This is really important for this paper because if you make a mistake and you've done it in pen, it gets messy really quickly. Answer all the questions. You can't get marks if you don't have a go, and use the space provided. Do all your working out in the book. Now the instructions say if your calculator does not have a pi button, then use 3.14. My advice is even if your calculator does have the pi button, still use 3.14 for all of your pi calculations. Because pi goes on forever, then you don't want to have lots and lots of decimal places. Use 3.14 for pi throughout this paper. The paper has 80 marks, so please be aware of how many marks are being given for each question. And some questions require you to write written communications. This means not just showing your working out, but writing down words and sentences to explain your answer. And in questions 15, 16 and 17 within this particular paper, that is required. And those questions will have an asterisk around them so you know which ones they're on about. You can ask for more paper, and in Unit 3, really important, ask for tracing paper. Okay, in this particular paper, it does come in very useful. On your exam, you don't know, but there's no reason why you can't ask for some beforehand. The most important piece of advice is, in all calculations, show how you work out your answers. There are more marks for showing your working out than there are for just writing the correct answer on the answer line. Inside the front page is a formula sheet. Now this formula sheet gives you the area of a trapezium and the volume of a prism. These are here to help you if they come up within the paper. These are not questions, these are just help should a trapezium or a prism come up in your questions. Let's start with the first question on this Unit 3 paper, which has a jug of water, and some water is shown in this 500 milliliter measuring jug. Question 1a is asking us how much water is in the jug. So this is a question on scales, and if this is 100 millilitres, then our water comes up to 50 millilitres. A nice gentle lead-in into the paper. Question 1b. 210 millilitres of water is added to the jug. On the jug, draw a straight line to show the new water level. So you're adding 210 millilitres to the 50 we already have. So you need to draw a mark at approximately the 260 millilitre level. Well, 250 is here, so dividing this gap between 250 and 300 into 5, it would be approximately there. So you would draw a line that goes approximately across your jug at 260 millilitres, just about there. Question 1c. How much water is in the 500 millilitre jug when it is 80% full? So this is a percentages question, and you can use your calculator. So 80% of something is 80 over 100 multiplied by whatever it is we're working the percentage of. In this case it's 500. So if you want to do it in your calculator, just enter it into your calculator straight away and it will tell you the answer to that problem is 400. If you're doing it in a manual way, you can do this first, where 500 divided by 100 gives you 5, and then you can do the multiplication. 5 times 8 is 40, and then add your additional 0 to get 400. So the answer is 400. 1 mark for the right answer, 1 mark for some form of working out. You have to show them what you're putting in your calculator, so they would require you to write something down. Question 2a shows a diagram of a triangle on a centimetre grid. Work out the area of the triangle. In maths, there are lots of ways to do these sorts of questions, and all of those ways are correct. All you need to do is choose the way that suits you. So you can either say it's a triangle, so it's half a square, and our square is a 3 by 3 square. So our square area would be 3 times 3, which is 9, and we would divide that by 2 to give us the area of our triangle of 4.5 centimetres squared. The other way of doing this question is to count the squares. So you can go round and count the whole squares. Counting the square method, you have 1, 2, 3, so that's an area of 3 square centimetres. Now this square and this square add together to give us an area of 4, and that leaves 0.5 with this square here. So counting our squares, you would end up with 4.5 centimetres squared. Either method is acceptable, and with 1 mark you don't have to show any working out. Now here, the diagram shows a shape on a centimetre grid, and they're asking us to work out the area of the shape. And it looks quite complicated because the corners are flat on these sides. Now, because it's question 2 still, it's generally going to be something to do with this triangle here on our original. Now we know our original triangle is 4.5 centimetres squared, and that triangle is the same as this triangle here, which is repeated 4 times. So if we have 4 lots of 4.5 centimetres squared, it gives us 18 centimetres squared, and that's just for our triangles. Then all we need to do is count the squares down the centre. So we have 1, 2, 3, 4, 5, 6, 7 across the middle, and then 1, 2, 3, we've counted the centre one already, 4, 5, 6 going down, so we need to add 13 to the 18 we already have. So that is 31. Again, don't be embarrassed, use a calculator to do all your basic calculations. And that is 31 centimetres squared, which is 1 mark for our correct answer, and the other 2 marks for the 3 marks is some form of working out to show how you got the area of the triangles and how you got the area of the 2 lines going up and down. Question 3 is about 2 judges who record the times of some runners in a race. The slower time for each runner is used as their official time. So it's in bold, that's a really important word there. The slowest time for each runner is used as their official time. Now the runners' names go down the first column. Judge number 1 looks like he's using minutes and seconds, and judge number 2 is using seconds only. Question 3a is asking us to complete the table with the official time in seconds. And again, that's in bold to tell us that's what they want the answers in. What we need to do is then convert our time from minutes and seconds into just seconds, and then compare the times for each contestant between Judge 1 and Judge 2 and find out who is the slowest, which means the one who has the longest time out of the 2 when we're comparing them. Let's show you that with Alf's time then. So 2 minutes is 2 lots of 60 seconds. So that's 120 seconds. Plus the 5 seconds we have here means that Alf from Judge 1 had 125 seconds and Judge 2 gave him 123 seconds. So the slowest time recorded for Alf is 125 seconds, and this is what we need to record as his official time. We do this process for all our other times. So 1 minute is 60 seconds, plus the 58 seconds for Ben is 118 seconds, and you can use your calculator for this. Judge number 2 gave him 115 seconds, so the slower time for Ben again is 118 seconds. Let's look at Carl. Carl had 2 minutes, which we know now is 120 seconds, plus the 8 seconds gave him a total of 128 seconds. Well, this is actually faster than the 130 seconds Judge number 2 gave him. So his slowest time in this instance is 130 seconds from Judge number 2. Then finally Dan. Well, Dan has 60 seconds for the 1 minute, plus 54 seconds is 114 seconds. When we compare the 2 times, Judge number 2 has a slower time for him of 115 seconds. So the official time for Dan is 115 seconds. And these scores here are worth your 3 marks. Now let's look at question 3b. Who won the race? Circle your answer. So the winner of the race has to have the fastest time or the lowest time. And in this instance, it's 115 seconds, and that is Dan. So we need to circle for our 1 mark the time for Dan. Question 4a. Shade 2 more squares and 1 more triangle so that the diagram has reflective symmetry about the mirror line. In order to do this, I would use tracing paper as the easiest method, where if we draw our mirror line and put an outline of our image, when we flip it over, so we take our tracing paper and we flip it, rotate it around and place the mirror line on the mirror line we had and the two squares that we do know with the two squares, it's easy to see where the additional two squares need to go. So we need to colour in this square here, and this triangle here. And then we have reflective symmetry about the mirror line. If you want to, you can use the perpendicular method where you count the squares across. So this corner here is 1.5 from our mirror line, so we need to go in the same direction at right angles to the mirror line, and that point is this point here. If we do the same for each of our points, we can reconstruct that square here. So this square has been reflected over to here. And we can do that for this square. So this square doesn't exist at the moment, so pick this corner and it's 1, 2 across, so 1, 2 places that corner here. This corner here, 1.5, so we count a half, 1, so it ends up there, and that means this square here is the same as our green square. And that just leaves the triangle. So this corner of our triangle here is half away, so it starts there. This corner here is a half away, so it's that corner there. And this corner here is 1 away, so it's that corner there. So reconstructing my triangle over this side, then the blue triangle reflects what we had on our object. So that's the other method to actually do this question. Question 4b is asking us to shade 2 more squares and 1 more triangle, so the diagram has rotational symmetry. So the best way to do rotation questions in Unit 3 is using tracing paper, and it has to have an order of 2, so it maps onto itself as it goes round. So we're going to take our object, and we're going to create an image that gives us an rotational symmetry of order of 2. The first thing we need to do is draw an outline of our object, which we've done in red pen, and then to rotate it around the centre of rotation, which is denoted by the blue dot. Now, unfortunately for me, I cannot rotate it around the blue dot using the software that I have on this computer, so you'll just have to imagine that I'm rotating this around the blue dot, and when it's rotated 180 degrees, we stop the rotation here. So our tracing paper now shows our outline. Now all we need to do is lift our tracing paper and draw in the 2 squares and 1 triangle that we need to complete this order of rotational symmetry of order 2. So this is our first square, and you can shade it in. This is our second square, you can shade it in, and then this is the triangle, and shade it in. Question 5a. The diagram shows box A and box B. Each box holds 4 weights. So box A has 3, 8, 10 and 12 kilograms, box B 4, 5, 6 and 15 kilograms. One of the weights is taken out of box A and the boxes now weigh the same. Which weight is taken out? Well, before we do this, we should add up all the weights. So you need to add the 3 to the 8 to the 10 to the 12. Do this on a calculator and show the examiner what you're doing. So 3 plus 8 plus 10 plus 12 gives us, using our calculator, 33 kilograms. And that's for box A. So box A has 33 kilograms. Do the same for box B, where you add the 4 to the 5 to the 6 to the 15. So 4 plus 5 plus 6 plus 15 gives us 30 kilograms. So box B weighs 30 kilograms. So in order to take out a weight from box A to make it the same as box B, it has to be the 3 kilogram weight. So you would circle the 3 kilogram weight, and now the two boxes weigh the same. Question 5b. Here are two boxes again, and they're the same weights in box A. So we have 33 kilograms in box A and 30 kilograms in box B. Now it's asking us, one of the weights is moved from box A to box B, and then the total weight in box B is now double the total weight in box A. Which weight is moved? Again, for 1 mark. So we have a total weight of 33 kilograms plus 30, giving us 63 kilograms in total. And we need to split that between box A and box B in the ratio of 1 to 2, because box B is going to weigh twice as much as box A. So it means we have 3 parts. So our 63 kilograms needs to be divided by 3, and it tells us that 1 part is worth 21. So I need box A to equal 21 kilograms and box B to equal 42 kilograms. So at the moment, box B weighs 30 and I need to get it to 42. So the weight that I need to move from box A to box B is 12 kilograms. So on your answer sheet, circle the 12 kilograms. Question 6a gives you a diagram of a triangular prism, and they want you to write down the number of faces, edges and vertices. So the faces are the actual shapes that we're seeing. So we have 2 triangles at either end, and then we've got 3 rectangles that go around the centre. So there are 5 faces to a triangular prism. Now let's look at the edges and tidy up our image. For the edges, you need to count each of these lines where the shapes meet. So for the triangles, there are 1, 2, 3, 4, 5, 6. So at either end we have 6 edges, and we need to count the 1, 2, 3 edges of the rectangles. So we have 9 edges. 9 edges. Okay, tidying up our image again. Let's look at the number of vertices. Now, in order to answer this question, you need to know what vertices mean. And a vertex is a corner. So we're counting the number of corners on our shape. So we have 1, 2, 3, 4, 5, 6. There are 6 vertices on our diagram. Okay, question 6b says the volume of the prism is 40 centimeters cube. Will the prism fit inside a cube with a volume of 125 centimeters cubed? Now a cube with this volume means that it must have sides, so a length, a height and a depth, all of 5, because 5 times 5 times 5 gives us our 125 centimeters cube for a cube, okay? And this should be a number that you recognize as a cube number. That's probably why they've given it to you. So the length of our cube has to be 5 centimeters. Now, we have no idea what the length of our prism is or the rest of the dimensions. So really, you cannot tell, because one reason could be don't know the length of our prism. And that's the reason that I would give. Question 7. 4 identical small rectangles are joined together to make a large rectangle. A is the point 6, 5. And what they want us to do is work out the coordinates for B, C and D. So this is a coordinates question worth 3 marks. So if A is 6, 5, on our x-axis, we know that this is 6. And we know that on our y-axis, this line is 5 high. So if all of the rectangles are the same dimensions, this must be minus 5 on the y-axis down here. So if we're looking at point B first, if it's 6 from here to here, it must be 12 from the origin to that point. Now let's look at all our coordinates. B must be 12 along the x-axis to get to this point, and then it must be positive 5 on the y-axis to give us 12, 5. C is 6 along the x-axis, but this time we're going 5 down the y-axis. So our coordinate is 6 minus 5 for the point C. And then finally D is 12 along our x-axis and 5 down our y-axis. So for our 3 marks, we should have B as 12, 5, C as 6 minus 5, and D as 12 minus 5. Question 8a. ABC is a straight line. Work out the value of y when x is 15 degrees. So we know that the first angle is 3x, which means 3 times whatever the value of x is. So 3 lots of 15 gives us 45 degrees. Again, you can do this on your calculator. Don't take any chances. Now, because ABC is a straight line, we know the angle has to add up to 180 degrees. So 180 degrees, subtracting our 45 that we know for 3x, gives us 135 degrees for y. Again, use a calculator to perform these calculations. On your answer line, 135 degrees is what they're after. Question 8b is asking you to work out the size of the angle x within this triangle. Now again, it requires you to understand that the angles inside a triangle add up to 180 degrees. Therefore, to find x, we need to subtract the 49 and the 84. Put this into your calculator, don't take any chances. When you've put it in your calculator, you should get the answer 47 degrees. Put in 47 here. If you know that the interior angles are 180 and you take away 49 and 84 and do it straight on your calculator, you'll lose a working out mark. You need the working out and the correct answer on the answer line for the 2 marks. So please show your working out. Question 8C. Work out the size of the angle Y within this shape. Now, you should identify this shape as an irregular quadrilateral because there are 1, 2, 3, 4 sides. And you should know that the interior angles of a quadrilateral, just like a square, add up to 360 degrees. So in order to find our angle Y, we need to take away all of the other angles and it would let us know what Y is. So subtract 26, subtract 190, as strange as it looks, and then subtract 15. And the answer will give you the angle Y. Again, use your calculator to perform this calculation. And in my calculator, it says it's 129 degrees. So you need to put 129 in here. Again, there are 2 marks. So some form of working out and the correct answer on the answer line. Also, look at your answer and look at Y and just generally ask yourself, does it kind of look right for what I'm expecting? And in this case, yes, it does. Question 9. The diagrams show a cuboid and its net, and the dot is shown on one of the vertices, on one of the corners. Okay, so on question 9a, on the net, draw 2 more dots to show where the points that meet the current dot show when the cuboid's made. In other words, when we take our original dot here, where else does it appear? Well, this is showing the dot on the side of our cuboid. So what we need to do is fold our net up and find out where this would end up. Well, when we fold it up, one of the places it ends up is there. And then when we fold the center of our net up, this corner here would then meet this corner here. So the dots need to be at the top right and bottom right of the net. And that's worth 2 marks. Question 9b. Again, this is to do with our original cuboid, but this time they're telling us the length is equal to the width plus the height. So the length of our cuboid is 7 centimeters, and the width plus the height is also going to be 7 centimeters. So if we choose one of these sides and one of these sides, so we have an L shape, those two together are going to give us 7 centimeters. Now, to calculate the length of all the edges and on our cuboid, I would start with adding the 4 lengths. So you've got 1, 2, 3, and one that you can't see at the back, 4 lots of 7 centimeters. So that's 28 centimeters. Use your calculator if you're at all worried about these calculations. Then what we need to do is add all of the sides from the ends. So we know that our 2 sides add up to 7, so this side plus this side will also add up to 7 with the original 7 we had at the start. So at each end we have 14 centimeters for our edges that we need to add together. So there's 14 at this end. If we have our edges here, so there will be 7 for those 2 and then 7 for those 2. So we need 2 lots of 14, which is another 28 centimeters we need to add to our original 28 centimeters. And when you add them together, you should end up with 56 centimetres as your answer. Question 10 shows a table with the stopping distances for a car when it brakes. And what it wants us to do is plot this data on a piece of graph paper, but most importantly, it wants to join the points with a smooth curve. It doesn't want us to do it with a ruler and a straight line. So it's kind of like a quadratic graph, but it isn't. It's just giving us the information. And the second bit of the question is asking us to extend the curve to estimate the stopping distance at 70 miles an hour. So the first thing we need to do is plot the 5 points they've given us from the table of speed against stopping distances. So on our chart, speed goes across the bottom and stopping distances in meters goes up the side. So for the first one, we need to show that a speed of 20 has a stopping distance of 12 meters. So we need to put a little cross of a speed at 20 and a stopping distance of 12 and place a little cross there on your graph paper. Then we need to do the same for 30 and 23 meters. So 30 miles an hour and 21, 2, 3 meters. Then we go to 40 miles an hour and 36 meters. So 40 miles an hour and 35, 36 meters. Place a little cross. I'm just moved slightly. There we go. Then at 50 miles an hour, we need to plot a point at 53 meters. So up 50 miles an hour to 51 to 3 meters. And then finally at 60 miles an hour, 73 meters. So go to 60 miles an hour and plot a point at 71 to 3 meters. So there are the points for our graph. And what we need to do now is draw a smooth line to join those points. So the method for doing this is to place your pen at the start of the curve at the 20 mile an hour point, and in one smooth motion move the pen up through each of the crosses and continue it past the last cross so that it goes to the edge of the graph paper, so you get a reading for 70 miles an hour. Let's have a go at doing that. Something like that. It's not an easy technique, and I'm sure the examiner will give you a bit of leeway if, like me, you've not got it exactly through each of the crosses, because it's a really difficult thing to do. Okay, so going back to question 10a, we've plotted the points and drawn the smooth curve as best we can. What we need to do now is extend the curve and estimate the stopping distance at 70 miles an hour. So we go back to our smooth curve and we go from 70 miles an hour and then look up the reading for the stopping distance. So let's do that. So what we need to do is draw a line from our reading of 70 miles an hour. Mine's slightly off, so I'll just move it a bit. That's why we use pencil in exams. Okay, and where it cuts my curve, I draw a line across to work out where it's hit my stopping distance. And again, I'm slightly out, so in the exam you'd have pencil, and I reckon it's about there. So reading off my chart, I believe it's 91 meters. So going back to question 10b, extend your curve to estimate your stopping distance at 70 miles an hour. It would be 91 meters, and that's what I'd put for the answer. And all that information came from the graph that we plotted, drew the curve for, and then read off our stopping distance for 70 miles an hour. Question 11a asks us to match the scales that are the same. The first one has been done for you. So 1 centimetre, and we know there's 100 centimetres in a metre, is 1 to 100, which is why they've drawn this line here. So let's do the same for the others. I know it's 1 centimetre is to 1 metre, sorry, to 100 centimetres to a metre. So in 5 metres, there would be 1 centimetre to 500 centimetres. So this square needs to attach to this one. 2 centimetres to 1 metre, well 1 metre is 100 centimetres, can be simplified. So this is a ratio they're asking us to simplify because we have no 2's in the first part of our ratio. So when I divide 2 by 2 I get 1, and I divide 100 by 2 I get 50. So 2 centimetres to 1 metre is 1 to 50. And then finally 1 centimetre to 2 metres, well that's 200 centimetres, gives me the match-up between these two. And this is exactly like the card matching that we've done in class. Question 11b is asking us about bearings. So now we're talking about bearings. We reference our bearings to north. So south, when we've got our cardinal points, north, south, east and west, has a bearing of 180 degrees. We do all of our bearings from north around to where we're going. So that's why we have south matched with 180 degrees. West, well west we have to go around a bit further by 90 degrees, so 180 plus the 90, it means that west is on a bearing of 270 degrees. Now they're asking us for some intercardinals. So north-east lives between north and east, and it's half of a 90 degrees because north to east is 90, northeast is 45. So the northeast card matches with 0, 4, 5 degrees. And then finally southeast. Well, southeast is between south and east in this general direction, and it's 45 degrees less than 180, or the other way to do it is add 45 degrees to the 90 for east. So 90 plus 45 would be 135 degrees. So southeast is mapped with 135 degrees. And for this, there are 3 marks. Question 12 has given us a diagram showing a parallelogram and a regular pentagon. So it's asking us to work out the ratio of the perimeter of A to the perimeter of B. So to find the perimeter of A, we need to add up all of the sides as we go around the shape. So we've got 3x, 5x, this side must be 3x, and this must be 5x. So add all the x's together. 5x plus 3x plus 5x plus 3x gives us 16 lots of x. For the regular pentagon, it's the same. You're adding up the sides. Because it's regular, all of the sides are 2x. And we have 5 lots of 2x. So 5 lots of 2x give us 10x. So working out our ratio of A to B, we have 16 lots of x to 10 lots of x. And what we're looking for are things that divide into both sides so we can simplify it. It might not be obvious, but the x's cancel each other out. If I divide both sides by x, I end up with 16 to 10, because x divided by x is 1, and both sides have an x. So now we're just dealing with numbers. I can divide both sides by 2 and I get 8 to 5 as my ratio. So I've divided both sides by 2 because I know 2 goes into 16 and 2 goes into 10. Now we're looking for a number that goes into 5 and 8. Well, there is no common number that goes into 5 and 8, so our answer is 8 to 5. And it has to be this way around because the question states clearly the perimeter of A is a ratio to the perimeter of B. So it's 8 to 5 as the answer. Question 13 gives us a cuboid, and it says work out the volume of the cuboid. So we need to multiply our length by our depth by our height. So it's 12 times 4 times 9. So show the examiner what you're doing and entering into your calculator. And I get 432. And 432 on the answer line. Now, every paper has this. State the units of your answer. And it's actually worth one of your 3 marks. Because at the moment, we have a mark for showing our calculation, a mark for showing the correct number on the answer line. But the 3rd mark, and this is one of those rare instances where there's 2 marks for the answer line, is centimetres, because they're our units, and cubed, to show we're talking about the 3 dimensions. So it's 432 centimetres cubed, and that is your 3rd mark. Question 14a is asking us to translate the triangle T by the vector 4 minus 5, and this is worth 2 marks. So you need to know what the vector is saying. The x direction is at the top and the y direction is underneath. So the 4 for the x is 4 to the right. And the y direction, because it's negative, is 5 down. So pick the corners of your shape and move them all in the direction 4 to the right and 5 down. So let's start with this point here. 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5 down. So that corner ends up here. If we do the same for the other corners, 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5 down, that corner ends up there, and the final corner ends up here. And then we reconstruct our triangle. Now, not only do you reconstruct the triangle, because they've given it a label T, to show it's the image, you need to label it T dashed to get both the marks. So a mark for translating it and a mark for labeling it T dashed. And that's what you've got to do. Label your diagrams if they've labelled them. Question 14b. It's asking us to reflect the triangle T in the line y equals minus 1. And there are 2 marks. And you can't get either of the marks unless you know how to plot the line y equals minus 1. Now, we stated in class, if you're struggling to work out what it means, put a little cross where y has a value of minus 1, which is there. And ask yourself, where else does y have a value of minus 1? Well, it has a minus 1 there and a minus 1 there. So the value of y equals minus 1 gives us a mirror line that goes horizontally like that. Okay? So try and remember where y equals a value, it's a horizontal line across your grid through that value. And in this instance, it's the number minus 1. Now we need to reflect our triangle. So you can either use the tracing paper method we used before, or use the method where you take each of the points. So this point ends up here. This point goes 1, 2, 3, 4, 1, 2, 3, 4, and ends up here. And this point, 1, 2, 3, 4, 1, 2, 3, 4, and then reconstruct your triangle. Again, not forgetting to label it T dashed. Okay? So the trickiest part of the question was working out where your mirror line is when you're given the equation of the mirror line. Question 15. A company claims the following miles per gallon for two cars. Car A has 68 miles per gallon, car B 55 miles per gallon. The driver of car A gets 30% fewer miles per gallon than claimed, and he drives 15,000 miles. Driver B gets 3/4 of the miles per gallon claimed and drives 12,000 miles. Which driver is using more fuel? You must show you're working out, and that's worth 5 marks. So there are a lot of marks here for some quite straightforward calculations. And you can do this question in one of two ways. You can work out the amount of petrol they've used and then adjust it by the percentage or the 3/4, or you can adjust the miles per gallon by the percent and the 3/4 and then divide that into the number of miles they have covered. And I'll use the second method. So let me show you for car A. It has 68 miles per gallon claimed, but it actually gets 30% fewer miles per gallon. So we need to multiply that by 30%, which is 30 over 100. And that will give us our reduction. So 60 times 30 divided by 100, again, always use your calculator, don't take a chance, gives us a value of 20.4 miles per gallon is the result of 68 times 30 divided by 100. Now what we need to do is take that away from what the company are telling us we get. So it's 68 minus 20.4. Again, use your calculator, don't take any chances. And the actual number is 47.6 miles per gallon. So that's what we're actually getting. So when we take our distance of 15,000 miles that we covered and we divide it by the 47.6 miles per gallon we now know our car is doing, we end up with the number of gallons of petrol that we used. And you should have a number around 315.1 gallons. Now let's do the same for car B, but instead of giving us a percentage, they've given us a fraction. So the company was claiming 55 miles per gallon, and we need to find 3/4 of it. And you can enter this straight into your calculator if you want. And it's 41.25 is the actual miles per gallon this car was giving us. So now what we need to do is take our 12,000 miles and divide it by the 41.25 miles per gallon we were getting for car B. And it uses 290.9 gallons. And that, again, using your calculator to do these. So 290.9. So which driver uses more fuel? Well, it's driver A uses more fuel. He used 315 gallons, where driver B only used 290.9 gallons. Question 16 is a wheel has a diameter of 0.7 meters. Question 16a is asking work out the circumference. So you're not going to be told this in the exam. The circumference of a triangle is pi times the diameter, pi d. So always use 3.14 for the value of pi, and your diameter is 0.7 of a meter. So the circumference of our wheel is 0.7 times 3.14, which gives us 2.2 meters. And I've rounded that to 1 decimal place because it was so close to 0.2. The actual answer I got on my calculator was 2.198, and this is so close to 2.2, for the sake of future rounding, I just put 2.2 meters. Question 16b, and it's got an asterisk, so it needs a written answer, says work out the number of complete turns when the wheel travels 1.6 kilometers. You must show you're working out. So we have 1.6 kilometers, which we need to convert to meters. So to go from meters to kilometers, we need to multiply it by 1,000. So it's 1,600 meters. So that's your first mark. Then, because our wheel and the circumference of the wheel is 2.2 meters, we have 1,600 meters, and every time the wheel goes round, it takes out 2.2 meters. So we need to divide 1,600 by 2.2. When you put this in your calculator, you get 727.27, and this is the number of turns. So they want the number of complete turns, so the number of complete turns is 727 turns of the wheel, and this gives them the writing they've asked for with the asterisk. Question 17 shows a diagram of a rectangle, and we have some algebra on most of the sides, but one of the lengths is 15 centimeters. Now question 7a is asking us to set up and solve an equation to work out the value of x. But because it's a rectangle, these two sides are the same length. So 15 centimeters is exactly the same length as 4x minus 5 centimeters. And hopefully, as soon as I write that down, you can see it's a two-step equation to solve it. So the first step is we add 5 on both sides, and we end up with 20 equals 4x. Step 2, we divide both sides by 4, and it tells us that x is equal to 5 centimeters. You can check it if you like. You can put 5 into here, so 4 lots of 5 are 20, minus 5 is 15. So we know that x has a value of 5 centimeters. Question 17b is asking us to work out the area of the rectangle. Well, to work out the area, we need to know the width times the height. So now we need to calculate the height of our rectangle in order to work out this area. That's why there's a lot of marks available. So looking at the two heights that we've got, they must be the same. So 5y minus 7 must equal y plus 3. And this is a three-step equation because we have our variable y on both sides of the equal sign. Now, I always taught you to move the y's together first, and then it will look very familiar. So move the least number of y's across to the more number of y's. So take y off this side, and you have to take off y on this side. And it leaves you with 4y minus 7 on this side, and the two y's here have cancelled out, leaving 3 on this side. And that should now look very, very familiar to you. It's a two-step equation. So we add 7 on both sides, leaving 4y equals 10. And then when I divide both sides by 4, do this on your calculator if you're not sure, you end up with 2.5 centimeters as the length for y. Now, we haven't finished yet because the question's asking us about the area of the whole rectangle. So we need to put this value of y into one of our two lengths here to make sure we have our length of our height here. So when we put 2.5 plus 3 into this side, we now know that our length of that side is 5.5 centimeters. And to work out the area of our square, we have to multiply our 15, which is our length here, by our 5.5 from what we've just calculated. Again, using a calculator, put it into your calculator, 15 times 5.5, and you should have 82.5 centimeters squared. Do not forget to write the answer on the answer line. Question 18, the final question in the exam, is worth 4 marks, and it's a right-angled triangle, and it's asking us to work out the length of x, giving our answer to 1 decimal place. So as soon as you see a right-angled triangle, the first thing you write down is Pythagoras' theorem. A squared plus b squared equals c squared. And then all you need to do is substitute the values you've been given to find out the thing that's missing. Now, because x is missing, x has to be the value of c squared because it's opposite the right angle and it is our hypotenuse. The longest side is always the hypotenuse, and the hypotenuse in our equation is always the value of c. So 9 and 16 can be substituted for a and b. So it becomes 9 squared plus 16 squared equals c squared. Then all we need to do is multiply out the numbers. So 9 squared on your calculator, if you want to, is 81, plus 16 squared on your calculator is 256, equals c squared. Now don't forget to keep writing the squared in until the end. When we add 256 to our 81, we end up with 337 is equal to c squared. Now, to get c on its own, we need to square root it, which means we also need to find the square root of 337. It's algebra. What you do to one side, you do to the other. So now, when you have 337 and you work out the square root, you end up with an answer of 18.357, and that's equal to c. Now the answer has asked for the answer to 1 decimal place. So the 1 decimal place is here, but because the next number along is 5, the 3 becomes a 4. So your answer needs to be 18.4 centimeters. And that is the end of the questions for this Unit 3 Foundation practice paper. If you have any questions or you'd like me to go through something in the classroom, please feel free to ask. Otherwise, it's been my pleasure, and this was an Archie the Pooch production. I hope you've enjoyed watching it. Good luck with your exams.